Hello students, and welcome to a how-to video on interpreting chemical equations. And when we're interpreting chemical equations, we're going to do it in two ways, in two terms, right? We're going to interpret this equation in terms of the number of moles and the masses of the reactants in the product. So moles and masses, those are the two ways that we're going to interpret this chemical equation. So let's scroll down here. So we've got hydrogen and nitrogen gas combining to form ammonia. And this is the example from the previous video, but I'm going to walk you through it. We're going to talk about each step, how we got there, etc. Okay. And before we can go anywhere, we have to balance this equation. So we have hydrogen and nitrogen. They're both diatomic. So let's write this out. We have H2, and it's a gas. All right, plus N2, and it's also a gas. It's going to form NH3, and it's also a gas. But is it balanced? We have 2 and 1 nitrogens, and we have 2 and 3 hydrogens. So everything's off balance. So let's balance this out. So let's start with the most left atom, and that's nitrogen. Hydrogen's kind of the exception. We always do hydrogen last. So let's do nitrogen first. We have 2 and 1, so let's add a coefficient of 2. Now we have 2 nitrogens and 6 hydrogens. Let's add a coefficient of 3 to get 6. So we have 6 hydrogens, 6 hydrogens. 2 nitrogens and 2 nitrogens. So this is now balanced. Okay, this is a skill you should have learned in the last chapter. Now, to calculate the number of moles, it's simply the coefficient that's found in front of the molecule that we're looking at. So it's going to be 2, 1, and 3. So if you write this down, we have 3 moles of hydrogen, 1 mole of nitrogen. I'll add 2 there. Okay. And we have 2 moles of NH3. Okay, so these are our amounts. All right, this is in terms of moles of interpreting this equation. And these are going to be the ratios that we're going to use to calculate future problems. Okay, so recognize that this ratio of 3 to 1 and 3 to 2, 2 to 1, this helps us figure out the quantities that we're going to need when we're doing these equations and we're balancing them. So now let's just break it down further and write it in terms of mass. All right, so let's do this. We have 3 hydrogen molecules. So when we calculate this, we're going to add it up on our periodic table. So I'm going to use this as my frame of reference. So we have 3 hydrogens. So we have 1.008 times 2, but we have 3 of those, so times 3. So we're going to have a mass of 6.048. So we'll just say 6.05. 5 grams of hydrogen. Okay, we have nitrogen, which is 14.01. Let me put it right here. 14.01. And it's diatomic, so there's 2 of them, so it's going to be 28.02. Okay, and because they're the reactants, we're going to add these numbers together. So we have 28.02 plus 6.05. So our reactants are going to weigh 34.07 grams total. So this is going to be our reactants. Okay, it's our total mass, right? This right here on the left side of the equation. Now, to make sure it's balanced, let's interpret it on the product side. So we have 2 NH3, so let's calculate what ammonia's molar mass is. So nitrogen 14.01, and we're going to times it by 3 hydrogens. So I'm going to do 3 times 1.008, put a parentheses there, and we're going to get 42. Oh, sorry, that messed up there. Here I go. I multiplied it. 14.01 plus 3 times 1.008. There we go. 17.03. That looks much better. Now, how many ammonia molecules are we making? We're making 2, so we're going to have to multiply it by 2. and that's going to be 34.068. So if we round that, it's going to be 34.07. So if I look at this, it's going to be 34.07 grams of ammonia, okay, or NH3. All right, oh, coming back, it's going off the page here. And if we notice, our products equal our reactants. This equation is balanced because based on the law of conservation of mass, okay, atoms are just shifted around. And so with those atoms, there's a specific weight to those atoms. Our weights should also, our masses should also be the same on both sides of the equation, okay? So I just broke down how to find the mass, and we just found the molar masses of the reactants, and we combined them, and then we found the total mass of the products based on how many there are present. So we now have a balanced equation in terms of mass, and we use these mole ratios to help calculate this. Okay? Thanks for watching.